Hey folks, welcome to CSE 1322. This is going to be lecture number 13. I hope you guys are all doing well. This is week 8 and we are going to today be talking about module number 5, which is recursion. We're actually going to have 2 lectures this week. So there's going to be this video and another one. Today I'm going to talk a little bit about the function stack. But before I do, there's a couple of quick announcements I want to make. The first one is that if you are in my section, which is the W01 section, the fully online section, if you go back and look at your quiz, you will notice that in Gradescope there is now a 7-point curve at the bottom. We did that because a lot of people struggled with question number 2, which was the one with the reference parameters. And so we just thought that we would go ahead and even that out because it seemed like a lot of folks had a hard time with that. So that is what's going on with that. So if you're in a different section, the curve may be slightly different. And I mention that only because I know some folks from other sections are watching these videos as well. So the curve was based on the average of each of the sections. So for W01, that number came out to 7. I think in some of the other sections, it came out to 6. So there you go. That's that. The other announcement this week is that quiz number 5, which you can see there in the schedule, is going to be published today or tomorrow, Monday or Tuesday, and then it will be due on October the 11th. So make sure that you get that one knocked out. You'll have a week. You actually had 2 weeks for the last one because of the weirdness of the scheduling, but normally you have 1 week. So that's going to be that. And then the other reminder is this line that's right here in the middle. October the 7th is the last day to withdraw without academic penalty. So if you want to get a W in the class versus a letter grade, then Wednesday is your deadline for doing that. If you're having a hard time and you don't know what to do, you are certainly welcome to reach out to myself via email and we can discuss it. You can pop into office hours on Tuesday or Thursday. Well, by Thursday it's too late, but Tuesday. Probably an email is probably the best way to go. There's also the academic advising team, and you could certainly make an appointment with them to discuss it if you're wondering about that. I'm certainly not encouraging anyone to do it, but I also realize that this is a weird semester and a lot of people are having just a hard time because of the fully online aspects and the fact that, well, it's 2020. I think everybody knows what I mean by that. So it's just been a weird year. So I could appreciate that some folks may not want to continue, and that's okay. We'll figure it out. Just let me know if you have any questions. You don't have to let me know if you're going to drop. You can just do it. But if you have questions or you want to talk about it or you want to discuss things. Regarding grades, one thing to remember is that we do drop the lowest quiz, and if your final is higher than one of your tests, it will replace one of your tests. So if you did badly on this first test, there's a couple of things to consider, which is, do you think you're going to do better on test 2 and the final? If you think the answer to that is yes, then it's still entirely possible that this test won't count for anything because the final would replace it. So, for example, you could have bombed test 1, but as long as you ace test 2 and test 3, you could still end up with an A in the class. But it really boils down to how well do you think you're going to do on test 2 and the final exam. So those are the thoughts there. All right, so I'm going to go ahead and get started talking about the function stack. And the reason that we're talking about this today is because it's an important aspect of recursion. In order to trace recursion and understand what's happening as one method calls another method, which maybe calls another method, which maybe calls another method, it's important to understand how exactly that works. And so this is probably something that you've intuitively seen before, and you probably already understand what I'm going to say, but it's worthwhile going through it one more time just to make sure that this is concrete before you go on to the next video where we're going to actually talk about recursion. So everything I talk about in this lecture isn't actually recursion, it's just simply methods calling each other. The next lecture is very specifically going to be about recursion, but again, it's important that you understand these basic concepts before you go on to the next one. All right. So we have this completely crazy code here, which it really doesn't do much of anything. This is simply here just to prove how things work within the stack. So we start off and we do have a main, which is down here. And I'm confused why it is not giving me, there's the little button. Okay, so our main method is down here at the bottom. And of course, it's main or main. It doesn't matter whether this is Java or C#, and likewise for strings. That's why we have it written that way. It works either way. And then we have two other methods, one that's called method 1 and one that's called method 2. Not very exciting. All right, so method 2 is going to be called inside of main, then method 1 is going to be called inside of main, and method 1 is actually going to turn out to call method 2. So that's what's going to happen here, but I just want you to see what it looks like when this actually runs. So what you need to picture is a stack. And a stack is a data structure which you probably mentioned in 1321 or in one of your previous classes. The concept of a stack is that the last thing that goes in is the first thing that pops back out again. So if you think of pancakes, pancakes are delicious. So pancakes are usually done in a stack. There's typically 3 pancakes. And if you're cooking the pancakes, generally you're going to take the first one off the pan, you're going to put it on the plate, then you're going to take the second one off the pan, put it on the plate, take the third one off the pan, and put it on the plate. And unless you are a barbarian, you are going to eat the first pancake, which is the one at the top. But that's actually the last pancake that was cooked. The last one that went onto the stack is the first one that you're going to take and eat. Now, I know you may just cut through all 3 of them and eat them like a barbarian, but that's not how you're supposed to do it. I'm kidding. But anyway, so a set of pancakes, important to think of them as a stack. I mean, they're literally called a stack of pancakes, right? The first one that goes on is actually going to be the last one that's eaten. The last one that goes on is going to be the first one that's eaten. And so that's the idea of a stack. So the way that execution happens inside of a program is also based on a stack. The first thing that it starts with, which is your main method, is actually going to be the last thing that gets finished. Everything else is going to happen in between. So let's look at what that actually means. All right, so we're picturing a stack as being this little area over here. In reality, that translates into an area of memory inside the computer, but the details of that are not particularly important. Just consider it as this magical place in which you have the execution of your program happening. So the very first thing that happens is that main is going to get pushed onto the activation stack. And this is a property of C# and of Java. They are both going to begin with the main method. So you don't ever have to call main, it just magically happens once the program begins. And so the main method appears to have 3 statements. It has a method 2 call, a method 1 call, and a print statement. So we're going to put those into the stack in order, like that. And we have a little pointer here which just tells us where we are in our execution. So the first statement that is going to be executed is this call to method 2. All right. So again, the main method got taken and was shoved onto the stack. The main method has a set of things that need to be completed, which are 2 calls and a print statement, and they're going to be on there until we get that done. At the very end of all of this, once we get to the end of the main method, this is going to pop out and we are going to be completed. So, all right, so let's do the first thing. So the first thing that's being asked here is a call to method number 2. And that's again because of this line over here. We are calling method 2. So what happens? Well, method 2 is a whole other method, and so that needs to be added onto the stack above the main method. And that's exactly what's going to happen. Method 2 gets pushed on there, and it has 2 statements. So they get put on there. So the first statement is just the signature of the method, which really doesn't actually do anything. That's what the 1 is there. And the second method is a print statement. So we're going to make our next statement. We are going to move forward in our stack. In general, the execution point, which is this red arrow here, is going to do whatever it's currently supposed to do. Then it's going to move on to the next thing down below it. And it's going to do that in each slice of the stack, as it were. So it did its print statement. And you can see that we get our output over here. Module 2 was called. That was our print statement. So again, to be clear, main called method 2. Method 2 had 1 statement, which was a print statement. It went ahead and did it. And then method 2 gets to its close curly brace. When it gets to its close curly brace, it realizes that this method is now complete. So what happens is that method dies and is removed off the stack, which is why we have a big X through it all of a sudden. And so the stack is now back to just the main method. And we're going to continue execution on the second statement, because the second statement is a call to method number 1. All right, so when we have a call to a method, the first thing that's going to happen is method number 1 is going to get pushed onto the stack. And method number 1 apparently has 3 statements. There's a print statement, there's a call to method number 2, and there's a print statement again. So the first thing that's going to happen is we're going to do this print statement. Method number 1 was called, and there we get our output. That's great. Now we're going to move on to the second thing, which is a call to method number 2. So what's going to happen is a new line is going to appear here, and method number 2 is going to be pushed onto the stack above it. Now it does remember in each of these methods where it left off. So there is a little arrow down there that tells you where you need to be. So it's important to realize that there's still stuff to do in main, and there's still stuff to do in method number 1. Both of those have unfinished code, but we're not going to deal with them right now because the next thing that we are supposed to do is we are supposed to call method number 2. So method number 2 is going to get pushed back onto the stack again. Now you might say, but method number 2 was already on the stack, right? Didn't we already do this? Well, yeah, we did it down here because it was called down here, but it's also being called up here. And so it's going to end up in multiple different places on the stack because of the order of things executing. Okay, so method number 2, as we've seen before, has 2 things that have to happen. Really, it just has the signature, and then it has this print statement. All right, so since it is the top of the stack, we are going to work on it. At the moment, the execution pointer is just at the signature. We're going to move on and we're going to do our print statement. So our print statement says method 2 was called. Great. We're going to move on and we get to the end of that method. And so as we remember, that means that method 2 is now dead and is going to be removed off the stack. And at this point, the top of the stack is back to just having method 1. We have just completed this statement, which was our call to method number 2. And now we're going to move on to the next thing, which is again a print statement. So method number 1 is still alive, is going to get printed. And now we have reached the end of method number 1 because we've reached that curly brace, and that means that we are done with the method. We have completed everything we were told to do. So it's going to die, and it's going to get removed off the stack, and we're going to return our execution back down to main. And that brings us to our print statement, which is where we left off. We had just called method number 1. It has completed, and so we moved on to the print statement. And so now we're going to do that print statement, which is going to say print finished. And then we're going to move on to the next thing, which is a curly brace. And when we reach that curly brace, we realize that main is now complete, and so it's going to be removed off the stack. Since there's nothing on the stack to execute, the program is done, and at that moment, it falls off the stack. There's nothing left to do. The program is over. Okay, so that's a trace through a block of code. It is really, really important that you are able to do this. You saw that there was a question on test 1, the very first question, where you had to make calls in and out of different methods in order to trace information through those methods. This is a very common thing. When you're debugging code, you're going to have to do this all the time because it's impossible to keep track of how things are going to look. So it's important to be able to draw these stacks like we just had here in this program and see what's going to happen. And it's important to remember, whether you do it down in a stack like this or whether you do it with little arrows like was happening over here on the side, doesn't really matter. It just matters that you're able to realize that you're going to come down, that's going to send you off up here. You're going to go through everything up here until you get to the end bracket, and then you're going to come back down and continue on to the next statement afterwards. And of course, there are things that could make this happen in slightly different order. Inside of method 2, you could have an if statement that calls return. And then instead of continuing on and doing other stuff up here, return could force you back to the method that originally called you. That's what a return statement does. The moment you hit a return inside of any method, it's simply going to kick you out of that method and send you back to the caller, this being the caller in that case. All right. So the important things to get out of this, this lecture. When you begin, you're always going to begin at main. Hopefully that's clear. You're going to execute the statements in order in main. When you get a call to another method like you have here, what's going to happen is you're going to remember that that's where you left off, and then you're going to do everything in the method that was called step by step, doing all of the things that it's supposed to do until either it ends or you hit a return statement. When you hit a return statement, you're going to come back to the previous method that originally called you and continue execution at the next line. And if that calls another method or sends you off in some other direction, so be it. You're going to follow that path very, very logically. I say all of this because a lot of people will just try and look at this code and decide what it's going to print out, and that's really not the way to do it. You actually have to follow it exactly like we just did in order to see which way it goes. And that's especially important when we're going to talk about recursion, which is what we're going to talk about in the next video, because with recursion, it's not that you are calling some other method, it may be that you're calling yourself. And that's the magic of recursion, is that you don't have to call somebody else. Sometimes you can just call yourself in order to help move the program along. So that's what we're going to talk about in the next lecture. We're going to go through a couple of examples of recursion. I hope that this was helpful with regard to how to trace between calls in and out of methods. And yeah, that's about all I've got for this one. So I will see you guys in the next lecture.